The Earth isn't flat. This is something we've known now for thousands of years. Aristotle proved it empirically by traveling to Egypt and witnessing new constellations of stars from the other side of the globe. After Eratosthenes used no more than a stick and light from the sun to calculate the Earth's circumference in the time of ancient Greece. Yet, throughout history, groups of people have been constantly re-emerging to push the notion that the Earth, our tiny blue planet floating in space, is in fact flat. The idea first resurfaced in recent history in the 1800s. Then, a society of flat earthers was set up in the 1950s, transforming the group from conspiracy theorists to an organization with thousands of members. As the internet began to grow in popularity, so did this organization. In no time, flat earthers began growing in number, attracting some pretty well-known members of society. These included movie stars, rappers, and professional athletes. Flat Earth theorists have different models supporting their idea. Perhaps the most popular is that the Arctic, or the North Pole, is at the center of the planet, while Antarctica surrounds its edges with thick and long walls of ice. A pancake-shaped Earth floating in space as the sun and other planets rotate above it like a celestial carousel. With all the evidence in the world to prove that this isn't the case, why do thousands of people still believe that the Earth is flat, including 1/3 of American millennials? The truth is a combination of a lot of different things that we really don't have time to go into in today's video, but with all the popularity this topic gets, it's only right that we ponder the concept. What if the Earth was actually flat? How different would our world be from what it is right now? First, if the Earth was flat, we'd all be dead, because gravity. Our understanding of gravity has developed throughout the years from being a force that pulls us towards its center of mass to being reimagined as the curvature of space-time that sets the course for planets to rotate around their stars. Gravity is the reason that Earth, and all other planets, are round. Imagining a flat Earth would mean that gravity, as we know it, must be having no effect. But let's say for the sake of argument that gravity would still have an effect. It's unclear how gravity would behave on a flat planet. Knowing what we do suggests that it would pull towards the center of the disc-shaped Earth at its North Pole, or the Arctic. This means that the further you get away from the center of the disk, the stronger gravity pulls you back towards the center. As a result, trying to reach the supposed ice walls of Antarctica at the edge would be impossible, as the gravitational pull would make it seem as if we're climbing a hill that only gets steeper. Oceans, seas, rivers, streams, and all other water bodies would converge at the center of the planet. Rain, snow, and hail would also fall towards the center, while trees would grow diagonally, developing in the opposite direction of gravity's pull. The effects of flat Earth gravity doesn't end here. As more air gets sucked into the Earth's center, it creates an atmosphere that would be lung-crushing close to the North Pole, and without enough oxygen to breathe at the outer edges. Earth would already be so uninhabitable to life as we know it, and it's only just the beginning. Without its spherical shape, our planet would lose its layered structure and behave very differently. Earth is made up of 3 layers, with the densest material sinking to the core, the lighter making up the mantle, and the lightest making up the crust. The outer core is composed of molten iron and nickel that acts as a giant magnet, creating Earth's magnetic field. It's what protects our atmosphere from the sun's harmful solar winds, and without it, our atmosphere would dissipate. Our oceans would spill into space, leaving Earth a lifeless, barren land similar to Mars. But suppose somehow we managed to survive all of gravity's grueling ways to destroy us. Our living experience on a disc-shaped planet would still be very different. Flattening Earth will increase its surface area by 2.5 times. This means traveling across the planet instead of around it would take significantly longer. It's also unlikely that satellites would be able to orbit, or more precisely, hover above a flat Earth. Without any satellites, we'd lose access to GPS services, leaving us without navigation, synchronized time, or the ability to perform all sorts of global financial transactions. Having no satellites also means that we won't be able to study our planet from the atmosphere. GRACE, the Gravity Recovery and Climate Experiment, for example, was a satellite that was launched in 2002 to take detailed measurements of the Earth and collect data to significantly enhance our understanding of global climate patterns. It's a mission still being carried on by GRACE-FO, which was launched in 2018. Without such satellites, our understanding of our planet would be limited. For a long time, humans thought that we were at the center of the universe. It wasn't until 1543 that Polish scientist Nicholas Copernicus first hypothesized that ours is just another planet, revolving around a star. Yet almost 500 years later, flat earthers still believe that we're at the center of the universe. They proposed this through two models, with the only difference between them being how the sun rotates around us. In the first model, the sun circles above the earth and sheds its light and warmth on certain regions like a high-powered desk lamp. If this is how our world was, we should be able to see the sun from anywhere across the globe, even if it isn't currently shining in that region. It would also mean that day and night as we know it simply wouldn't exist, because if the sun doesn't rotate, then it shines on the same parts of the globe all day long, leaving some places in eternal sunshine and the rest of the planet in utter darkness. To help account for the day cycles, the second model proposes that the sun is rotating spherically around the earth. If this happened, our entire planet would witness daytime and nighttime simultaneously, because the whole planet would be brightened and darkened at the same time each day. In both of these models, there would be no time zones, no seasons, and no moon in our depleted atmosphere. The view of the night sky would be the same from anywhere in the world, and our view into space would be limited to the patch of the galaxy directly above us. Because, again, without any rotation, we'll be staring at the same thing every single time we look up. It gets worse. If the sun is as big as it currently is, it would burn the planet. On the other hand, if it was as small as these theories suggest, then Earth would freeze because sunlight wouldn't be able to reach its increased surface area. It seems that all iterations of the flat Earth theory end up with the destruction of our planet and everything in it. Shouldn't the fact that we're alive then be proof enough that the Earth is round? In theory, it should, but facts don't change minds. I made an entire video about this if you want to check it out. Link is in the description. But the truth is that humans have known for a very long time that the Earth is, in fact, round. Around 500 BCE, Pythagoras first proposed that the Earth is spherical. While his findings were not based on any physical evidence, he believed, along with many Greeks after him, that a spherical shape simply made the most sense. Over a century later, Aristotle was the first to provide empirical evidence of Earth's rounded shape, listing many arguments, such as ships disappearing hull first when they sail over the horizon, Earth's round shadow on the moon during a lunar eclipse, and different constellations being visible at different latitudes. The Greeks believed so much that our planet was round even in times with very limited technology, that they went as far as measuring out its size. In 276 BCE, Eratosthenes discovered that the Earth's circumference to be 40,250 to 45,900 kilometers, or 25,000 to 28,000 miles, simply by using the shadow of a stick to measure the angular displacement of the sun in two different locations. He then multiplied the angle by the distance between the two locations and gave us our first estimation of the size of the planet. And the thing is, he wasn't that far off. Earth's actual circumference is 40,070 kilometers, or 24,901 miles. If you're wondering, we measured it using an orbiting spacecraft. Apart from being such an astonishing feat, measuring the Earth using the angular displacement of the sun in two locations was also another piece of evidence to prove that the Earth is spherical. On a flat plane, the shadow cast by the sun would be the same length everywhere. It's only because of the Earth's curvature that the sun can shine on one part of the Earth at one angle and on another part of the Earth at a different angle, causing one shadow to seem longer than the other. Following the Greeks, Islamic scholars made further advancements in the 9th century. Then European navigators circled the globe in the 16th. Finally, in the 20th century, we sent spacecraft, satellites, and probes into space, all of which brought back astonishing images of our big blue planet. Time and time again, through different pieces of research done by various communities around the world who don't agree on a lot of things, we've proven empirically, mathematically, and scientifically that this little rock we all call home is round. But if we're being honest, it was never really about the evidence. Believing in a flat Earth is a form of science denial, where people entirely question the main premise behind scientific ideas. Science denial is usually linked to a conspiracy mentality that makes people susceptible to wrong ideologies about all things science. What all these people have in common is a denial in the scientific process and a disgust for organized institutions like governments and research agencies. While believing in a flat Earth doesn't seem to be as harmful as not believing in climate change, for example, conspiracy theories in general become dangerous when they gather a large following. So large that they start to affect some changes in the policies and decisions of a society. Lee McIntyre, a philosopher from Boston University and an expert on science denial, believes that if these misguided ideas aren't challenged, proponents of a flat Earth will start running for US school boards, looking to push their ideas into the US education system. Because conspiracy theorists are generally highly skeptical people who have lost their trust in authority, while we understand that facts don't always change minds, perhaps instead of arguing the evidence for a spherical Earth, a better approach would be to help these people reestablish their trust in science. Make it about the emotion instead of the facts, because even in face of overwhelming counter-evidence, people are most likely to cling to their beliefs. Instead of patronizing flat Earth proponents, science needs to take their questions seriously and answer them patiently and with a level of sustained engagement. Flat Earthers may distrust science today, but approaching their uncertainties with a lower level of scrutiny could help against the spread of misinformation and deceptive claims. Be that as it may, there's still a special appeal to the flat Earth theory. Not because it holds any scientific merit, but simply because it allows us to imagine how unforgiving the universe could be if the conditions were any different. Our planet's uniquely built to sustain millions of life forms, and its spherical shape is essential to our survival. This is the most famous image taken of our planet. It's called Earthrise, and it changed our relationship with our home forever. While earlier spacecraft had taken images of Earth, this is the first one taken by an awestruck astronaut holding a camera. When William Anders took this picture from the moon's orbit in 1968, he offered us a one-of-a-kind glimpse at the rock we all call home and its place in the cold, dark universe. It's almost as if humanity was able to look itself in the mirror for the first time. Take a deeper look at this image. Right now, all of us are somewhere on this little blue ball, half submerged in darkness, quietly floating in empty space. We have a protective atmosphere to shield us from the harmful rays of the sun, breathable air, and oceans of water integral to our survival. The sun gives us light and energy, and gravity keeps us rotating at a safe distance from it. This tiny blue ball floating in the darkness of space right now seems to be the only place in the observable universe with just the perfect conditions to spawn life. So no, Earth isn't flat. But why would we ever want it to be? Today's video is sponsored by Brilliant, one of the best places online to learn anything and everything STEM related. In today's video, we talked about how when trying to disprove a conspiracy theory, it's not really the evidence that matters, but the trust in that evidence. To build trust in the scientific community and the evidence they provide, the best thing we can do is to teach science, technology, engineering, and math courses in a way that's not intimidating to people. This is why I love Brilliant. Brilliant is an amazing tool to learn these STEM courses interactively. With courses like scientific thinking, Brilliant doesn't just teach you theory, they help you understand how these theories affect our daily lives. As a result, it's easier to trust the information being presented to you because it's something you can observe yourself in everyday life. With Brilliant, you can learn at your own pace and from anywhere in the world too. If you're interested in learning more, I highly recommend you check them out. It's free to start, but the first 1,000 people to visit brilliant.org/aperture can get 20% off a premium subscription, which unlocks every single course Brilliant has to offer. There's always a lot of value there, and I've used them personally to help create videos in the past. You'll not only be furthering yourself, but you'll be supporting Aperture at the same time.